Hello guys, welcome to the series of data structures and algorithm. So from today we will be start learning data structures and algorithm, and we will start from the very beginning from the data structure part 1, the normal fundamentals of data structure. So this is the first video and let's start. Before we go through what is data structure is, we need to know few terms about what are variables, what is the data structure, what are the types of data structure. So in this video we will discuss all the brief things about data structure that you need to know before moving to the data structure. So let's start. First we need to know what is variables. Variables is placeholders where data can be stored is called variables. Variables is placeholders where you can store the data. These are variables. Let's suppose take an example. X minus 2x, that is equals to 0. So you can easily figure out the value of x here. That is, what is the value of x? Here x, the value of x is either 0 or that is 2. So you might be thinking how we got it. X into x minus 2. So that is 2. So here the value we got, x equals to either 0 or 2. That means what? X can store data. X can store data. It has stored 0 or 2. That means something what can store data that we can declare as variable. Something that can store data, that is called variables. So simple. Placeholder where data can be stored is called variable. Variable can be anything like A, B, C, D, etc. Hello, etc. Just you need to declare that type before you, in any programming language you need to declare that type as according to the syntax. Sometimes you need to, like if you are in the main languages like Java, you have to give it like integer A. Suppose you are in PHP, then you have to give $A. So this is the way how you can define the variables in different languages. Now coming to the data types. What is data type? We are in data structure. So you must know about data types. That is, what is data types? So there is two types of data types. One, first, that is system defined data types, and second, that is user defined data types. So system defined data types, that means system defined, that means data type what is defined by the system is called system defined data types. So simple, like integer, float, double, bool, etc. These are the data type. These are already previously defined in the system. So these are called system defined data type. So you might be thinking, what is integer, what is float? I think you have a brief idea. Integer is something like 0, 2, etc. integer, and about the double and float, like suppose 2.5, 3.5. So these are called float or double. Float has a range, a short range, and double has a long range. So these are all comes in the system defined data type. Now coming to the user defined data type. Now we came to user defined data type. So user, who are the users? We are the users. You are the users. So that is called user defined data type. That means data type that is declared or that is defined by us. That is called user defined data type. So this is user defined data types. Example, structures in C++. You already have studied the extract function, enum function in C, C++. So that is defined by us. Classes in Java. We all know that Java is a combination of classes. That everything in Java is all about classes. So the classes, this class is also a user defined data type. That means the class we define, that is also defined by us. Now coming to the data structure. That what is data structure? Data structure is a particular way of storing and organizing of data. Particular way of storing and organizing our data in a computer so that it can be used efficiently. That means what? Data structure is a way how you can organize the data particularly. Suppose you have a lot of data. Like take it here. 2, 3, 5, 9, 10, 15, 1, 7, 6. So look the data. This is not organized properly. Here there is 2, here this is 1, here this is 6, here this is 5, here there is 7. So the data is not organized properly. Now we can organize the data in a proper way, like 1, 2, 3. 1, 2, 3, 5, 6, 7, 9, 10, 15. So now look this. This is a proper way. This is a proper way of organizing the data. This system, the system of defining the data in a proper organized manner is called data structure, and that is why what we do in the entire data structure. We will start from the array, then we will move to the linked list, then we will move to the queue, then we will move to the stack, then after going to the stack we will go to the graph, we will go to the trees, etc. we'll move into a lot of portion, and we will see everywhere that this is all about arranging the data properly and in a systematic manner, and that's the entire data structure. So data structure, a special format of organizing and storing data. A special format, as I said, arrays, files, linked lists, stack queue, etc. graph are data structures. Arrays, linked list, as I said. Now coming to the type of data structure. Data structure are of two types. First, that is linear data structure, and second, that is non-linear data structure. Look, come on. This is how we represent an array. We represent an array in the systematic manner. This. The index starts always from 0 in computer programming world. So this is 0, 1, 2, 3, 4. So we can store any data here. 10, 12, 5. So this is what? This is a linear data structure. Why? Because this is in linear pattern. If you come to the linked list, we can see single linked list like this. So this is the linked list will point to each other. So this data structure is also in a linear way. So this is also a linear data structure. Now if we come to such data structure of that type, that there is 3, 4, 5, 2, this is connecting here, this is connecting here, this is connecting here, this is connecting here. So this is not a proper data structure in a linear pattern. Look this pattern. Is this a linear? No. So this is a graph, that is non-linear. That means what? Non-linear. This is linear. Linear, number one, and second, that is non-linear. Non-linear. Now if we come to the trees part, like this, few data structures are like this. So this is also a non-linear data structure. So this is here. The data structure are of two types. First, linear data structure. Second, that is non-linear data structure. So after we came here, linear data structure and non-linear data structures. After the types of data structures, after knowing the data structures, we'll move forward the abstract data types. So abstract data types. What is abstract data types? To simplify the process of solving problem, we combine the data structure with the operations. We call this abstract data types. That means to simplify the problems of data structure, we combine the problems with their operations and instructions. This entire process is called abstract data types, or ADTS. Look, to solve any problem we need certain operations, and the combination association of certain operations, in simple word, it's called abstract data types. And now an abstract data type consists of two parts. Abstract data type दो पार्ट को लेकर कंसिस्ट होता है. One, that is declaration of data. That is first when you declare the data, like this is integer a, b, etc. or string name. When program you define the data in this way. So this is the declaration of data is the first part. Now in the second part, that is declaration of operations. Now inside we made the functions, we made the operations, and we define the entire operations, how our program will execute the certain program. This is called the declaration of operation. So the declaration of data and declaration of operation, this consistence is called abstract data types. And the commonly used abstract data types are linked list. Linked list that I have discovered like this. This structure is called linked list. Now stack, queue, binary tree, disjoint set, hash table, graphs, etc. Algorithm. An algorithm. Now you might have listened that what is algorithm. So algorithm is the certain instructions, one by one steps to figure out or to solve a certain problem. These are called algorithms. An algorithm is a step-by-step unambiguous instruction to solve the problem. So the instructions to solve a problem is algorithms. Suppose we want to find the solution of Kruskal's algorithm. So this is the algorithm to find all the problems of Kruskal's that uses the divide and conquer. So these are having certain instructions, and those instructions that are commonly called the algorithms to solve a problem. So this is algorithm. Now we will move towards the time complexity. So we knew about the algorithms, and to solve the algorithms we need certain amount of time. Suppose there's a algorithm, we're taking a little amount of code. So look, we just took a little code, and from guess what is the time complexity of this code. what is the time complexity of this code. This is also a small part of algorithm. An algorithm is combination of the small parts, small instructions, and that take a amount of time. So it is very much important and crucial for algorithms to have the time complexity, to have the as minimum as possible time complexity. And that's why in algorithm we always take the two upper and lower side, that means the best case and worst case time complexity in algorithm. So look, what should be the time complexity of this algorithm. This is, here the loop starts. So this will take 1 unit of time, and this will take, it will take from 0 and it will run up to 0, 1, 2, dot 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 up to n minus 1. That means it will run up to n times. So total the loop will run for n plus 1 times. Here this is n times and this is 1 times. So here the time complexity we can call that the time complexity is big O of n plus 1. That is big O of n. So the time complexity is here the proportional to n, and this n is called the linear functions. So that's how we define the functions, and we call them certain names. So we look the functions and we'll briefly discuss about the functions. Look, first there are certain few functions those always takes a constant time, like the declarations of variables int a, int b, etc. They always take a constant time. So these are called constant function. Whatever the input size, function takes a constant amount of time. Constant functions always takes a constant amount of time. Now coming to the logarithmic. Log faster than constant but slower than growing. When we will get a log n, so that is a logarithmic function, it is faster than 1 and it is slower than linear function. After that linear that comes n, that is a linear function, grows linear with input size n. This is linear is like this. As the input size grows, the function also grows keep. Now coming to n log n, this is linear logarithmic. So this is faster than linear but slower than quadratic. Quadratic are those that are in square form. In square, that is a quadratic function. N cube, that is a cubic function. 2 to the power n, that is exponential function. N factorial, that is factorial. 2 to the power n is faster than all of the above. So what is the relation? As we go below, as we go down, the speed of the function keeps increasing. So we can write here that as we go down, functions, as we go down, the fastness increases. So as we go down, the fastness increases. Here the quadratic function, cubic function is more faster than quadratic, exponential is more faster than cubic, quadratic, etc. So this is our function. So we already took the brief idea of what is data structure is, what is algorithm is, what is variables is, etc. Now we will, in the next lesson, we will move forward to know very important things, the notations, big O notations, sigma notations, and omega notations, which are the lower bounds and very crucial for data structure and data structures in for knowledge purpose also, and for college or study materials also. So for this video, okay, thank you, that's all, bye.